Hi everyone, this is Rebecca, and today we'll be going over the CS 88 midterm question 2, spring 2022. All right, so this one is called soft drinks, and it says, fill in the blanks to complete the environment diagram. All the code used is in the box to the right, and the code runs to completion with no errors. Some arrows have been removed from the diagram. You may wish to draw in those arrows, but it is not required. Okay, so since this is an environment diagram problem, sometimes I prefer to just draw the environment diagram separately myself, but in this particular case, we'll just work with the template that they give them. But if you find it more helpful to just start from scratch and not be distracted by the stuff here, then feel free to do that as well. Okay, so let's take a look at the code line by line. So the first thing we have here is this Coca-Cola function definition. And we can see in the global frame here as well that the first kind of like name that we have is Coca, which points to the function Coca, which takes in a parameter cola, and Pepsi, whose parent is global, which is what we expect. And then remember that when we are doing environment diagrams and we see a function definition, we only like bind the function name to the function itself, and we ignore the stuff in the body for when we actually execute the function. So you can kind of ignore lines 2 through 6 until we actually call Coca. Okay, next we have doctor, which is once again another function definition, except this one is a lambda function. So you can see over here in the global frame, we have the doctor name pointing to the lambda function on line 7. You might be wondering why we have this line number here, because normally we don't put the line number for function definitions, but for lambdas in Python Tutor, they do include the line numbers. And this is mainly because lambda functions are anonymous, right? So they don't have a name, which means that we can have like multiple lambda functions, and it gets kind of confusing when you have like func lambda and you're like not sure which lambda you are talking about if you have multiple lambda functions. In this particular case, you don't really need to have it, but you know, they include it in the template. All right, and once again, we don't really look at the body of the lambda function at all. We just continue on. So next we have this pepper list. So we can kind of draw this in here for E, which currently points to this kind of box diagram here. We have 7, 8, and 9. Cool. Next we have this cola variable, which is just 2. And then we have soda, which is supposed to return 4. And we can kind of see once we look through the rest of the code if this is true, and if it is, then it probably means we did the environment diagram correctly. Okay, so let's see. Soda is the return value of calling Coca on pepper and doctor, and then the result of calling that with cola. So we can kind of see already from the structure here that this Coca, pepper, doctor should return like some kind of function. Okay, so looking at Coca, right? When we call it, we open a new frame here, which is frame 1, whose parent is global, right? Because the Coca function's parent is global, as you can see over here. And then remember, the first thing that we do when we open a new frame for a function call is that we bind the arguments to the parameter names. So here, cola is bound to the value of pepper. So cola here, we should make this arrow point to the pepper list. And then doctor is the value that's passed into Pepsi. So Pepsi points to doctor, which is this lambda function over here. Cool. And inside, and then, so now that we have bound the parameters to their values, we can now execute the function. So we see here that there is a nested like function definition, def mountain, which takes in the parameter do. So we can just, well, the template already did this for us. So there's the function that mountain is pointing to. And remember that the parent of the function is the frame in which the function was defined in. So in this case, we're currently in frame 1. So A is function, or sorry, frame 1. All right, and remember we skip the body of the function and we go to the next line and we see that we finally just return the function that we just defined, which is mountain. Okay, cool. So, and this matches with our intuition from before over here. We can see that Coca indeed returned the function. Specifically, it returned the mountain function, whose parent is frame1. And now we are going to create a new frame because we're calling that mountain function. Once again, this is the same as what we had over here. So I'm just gonna say like F1 to remind ourselves. And then once again, the first thing we do when we open a new frame is we bind the parameters to their values. So do, what is passed into do? Well, we see here on line 10 that cola is passed into do. So in order to, since cola was from the global frame, we'll look at cola over here. And we see that, sorry, that was a bad arrow. So cola over here, and we see that cola has a value of 2. So B is 2. And then we want to then see what mountain actually does in the body of the function over here in order to see what it returns. So we see that it does cola dot append do. Okay, so you might be wondering which cola are we referring to? Are we referring to the cola in the global frame or something else like the cola that is the parameter of Coca? And the answer to that is basically with our environment diagram rules, right? So the rules say that if we first want to look for variables or like names in the current frame that we're in, right? So the current frame that we're in is frame 2. Do we see anything that's called cola? Well, we only see do, right? So if we don't see the name, we go to the parent frame and we do the same thing. Is there a cola? So the parent frame of mountain is F1, right? So we go to F1 and we look for a cola. And here, indeed, we see this cola over here. And what does it point to? It points to the 789 list, right? So when we're appending to this cola, we're appending to the 789 list. We append do, which is 2. So now the list becomes 7892. Okay, cool. Next, we have line 4 of the code, which says cola of do is equal to Pepsi of do. Okay, so we already figured out that cola refers to this list over here. So if we do cola of do, that means we're doing the second item in the list, or I should say the element at index 2 of the list. So if we kind of write out the indices, let me pick a better color. So this is index 0, 1, 2, 3, right? So we're changing this element here, and we're changing it to be the value of calling Pepsi of do. Okay, now we have to open a new frame once again. I'm going to change colors just for variety. So now we have to look, what is Pepsi, right? We don't see Pepsi in the current frame F2. So we go to the parent frame F1, and we see that Pepsi over here is pointing to the lambda function that we defined earlier. So now we go into this lambda function and open a new frame to actually run the code in it. So now we have a new frame F3 of the lambda function, and we bind the values to the parameters. So we see here the lambda function takes in one parameter called x. And what do we pass into x? Well, we pass in do. And this do is from F2, which we know has a value of 2. So in other words, x is bound to the value of 2. And we see that the lambda function here returns x plus 1. So we now know that the return value here is x plus 1, which is 2 plus 1, which is just 3. Cool. And so going back to line 4, right? Pepsi of do is just 3, right? So in other words, what's really happening here is cola of 2 is set to 3. So we kind of just erase this 9. Oh, oops. We erase, let me make this smaller. So we erase the 9. Okay. And we change this to a 3. Okay, cool. And finally, the last thing that we do in frame 2, the mountain function, is we return the length of cola. And once again, cola is this list over here. So the length of that is 4. So the return value here at C is 4. So to kind of sum up, what you should get for part A is F1. So that's a bad one, F1, okay. And then for part B, we have 2. For part C, we have 4. For part D, we have 3. And then for part E, the list that we have is 7, 8, 3, 2. All right. And yeah, that's how you do soft drinks.